Hello everyone. So now let's look at the equation of straight line, and in this first video we are going to look at symmetric and parametric equation. So let's say we have 2 points given in the blue color circle here, and at the tail of this vector represented by the orange color, we have r0. So r0 is x0, y0 in a 2D plane. And then at the head of the vector we have r, which is xy. So xy is going to give us the coordinate of this point. So now in this vector, basically we can have the slope of the vector, which is just simply the ratio of y minus y0 over x minus x0. So we are very familiar with this. So now let's say there is another vector, which is a, and this vector a is parallel to the vector r minus r0. And here, if you have this vector a and this vector in the orange color, r minus r0, to be parallel, it means the slope is going to be the same. So this just means that the slope is going to be equals to y minus y0 divided by x minus x0, and this is going to be equals to b over a. Now we just have to rearrange this equation so that we bring x minus x0 to the right hand side of the equation, and now we get what we call as the symmetric equation of a straight line. So here you have x minus x0 over a equals to y minus y0 over b. This is when the case when c is equals to 0. Basically, there is no change in the z-axis, or basically you are just working in the 2D plane. So when you have c which is not equal to 0, they are the same, except that now you have the third component, which is z minus z0 over c. Okay, so this is what we call as a symmetric equation. So now let's look at another way to represent the straight line, that is by using this equation r equals to r0 plus at. So here what it means is that when you go from r0, which is this point, and you add the number of vector a in the same direction, then you will reach the point r, right? So here this is what it means by this expression. So when you shift r0 to the left, you have r minus r0. So r minus r0 is basically this vector, and this is equals to how many times, which is t, of the vector a. So let's just show it like this. So here, let's say this is supposed to be a r0. So r0 to r, so here is one vector a, and then let's say we have another vector a. So in this case, my t is equals to 2, right? So in this example, my equation of straight line is going to be equals to r equals to r0 plus 2a. Right, so this leads us to the parametric equation. Let's look at the next slide. So when we write r equals to r0 plus at, we have to recall that r and r0 basically is made up of the coordinates of the points. So for a 2D you have xy, for a 3D you have xyz. So when you write the parametric equation, basically you write it in terms of the component. So here x, which is the coordinate for the point r here, is going to be equals to x0, which is this point, plus a, small a, times t. So small a is basically the component for the vector a along the x direction. So similarly, this is the case for y and z. So right, this is our parametric equation. So what we have seen here is that there are two ways to write the equation of straight line, that is the symmetric equation and the parametric equation, like what we are seeing. Okay, so that is all for the parametric and symmetric equation. In the next video, we are going to look at how to find the line which is perpendicular to a given vector in 2D case. Alright, so till then, see you.